You should have out your science journal and your vocabulary list. If you haven't already gotten one started, then please go ahead and do that because we're starting a new unit. Today we're talking about solutions. And yesterday we talked about, as a review of some of our chemistry ideas, how you can add, by adding heat to a substance, particularly a solid substance, or any substance, that you change the kinetic energy of its molecules. That is what heat actually is. It's the kinetic energy of molecules. And I used as an example sodium chloride, which is, of course, salt. And salt. And in this gizmo, you can turn up the heat. It's already pretty high. And you can turn up the heat and add more heat. And in doing so, you can actually cause those, every time you add more heat, you're adding more vibration to those solid molecules. And eventually they liquefy and they start moving about like that. So we know that that's one way of turning them into a liquid. But what I want to explain today is that there's another way to do that, of liquefying solids. And in certain types of solids, you can dissolve them. And we all know that salt is an example of something that does that. When you dissolve them, it is what we call a solution. So dissolving one material into another equals making a solution. Let's define that word. So a solution, if you could say that word, I know you know how to say solution, is a mixture that forms when one substance dissolves another. So to start with, in order to make a solution, you need a solvent. And the universal solvent is water. Can we all say solvent? Why is it water? Because water is very good at dissolving substances. And a solvent is a liquid that is capable of dissolving substances. So water is a very common solvent. The opposite of a solvent is a solute. Can you say solute? Great. And a solute is a substance that is dissolved in a solvent. Other substances can be dissolved in water, and you know that water can dissolve a lot of things in it. You've heard of mineral water. That means that it has all different types of dissolved minerals in it, including halite. We also know that water molecule, that water has carbon dioxide dissolved in it, especially when you release your soda bottle. It actually then becomes a gas because more carbon dioxide will actually stay in solution in water under pressure, and that's why we release that. I'm sorry, this is carbon dioxide, forgive me. And we also know that something like hydrochloric acid can dissolve in water. So we know that water is able to dissolve a lot of things. And we're going to take a look at the halite example again to understand that. A reminder that halite is a cubic structure that is made up of sodium atoms and chlorine atoms, and they're in this kind of perfectly cubic structure, and that's part of the reason why salt crystals are always cubic and they always break into perfect cubes, is because that's the structure of their atoms. So I'm going to show you a video here of salt being dissolved in water. And I want you to notice that we have water molecules. In the model I'm holding, the oxygen is red, but in the model here, the oxygen is actually blue. And the white hydrogen atoms are shown as green in this model. And back here we have halite made up of sodium and chlorine. And in this particular video, I believe the sodium is the purple and the chlorine is the yellow. And what I want you to notice is that, well, let's just go ahead and watch what happens. So water molecules pull the sodium and chloride ions away from the crystal, dissolving the salt. The word ion refers to an atom that has a charge. And to remind you, I don't know if you remember this, but this is why water is a universal solvent. It's because one end has a slightly positive charge and the other end has a slightly negative charge. And I just want to add that. This is because water, the water molecule has a magnetic charge that attracts it to other atoms and molecules. And that is part of the reason for that. So again, watching this take place, you can see, again, this is kind of a back view of if I was to put this in water, what would happen eventually is that those water molecules would go in and gradually pull apart individually each one of those atoms in order to, and eventually those atoms would kind of freely float in the water and be surrounded by other water molecules, and they would, and that would be what would happen. Another thing that I want to point out here is that the faster the molecules are moving, in other words, more kinetic energy, that allows them, the more solute it can hold. Okay, and this gets us to our next idea, our next vocabulary word, which is the idea of solubility. How much can salt dissolve in water? How much water or how much salt can water have? And so solubility is a number. Usually it's a measure of how much solute can dissolve in a given solvent at a given temperature. If you wanted to test this and your parents allow you to use some salt for this, you can actually take a small amount of water and add some salt a little bit at a time and dissolve it, and you'll see at a certain point that the salt will no longer dissolve, that it will start piling up. And the reason that has happened is because it's reached its saturation point. Can you say saturation? So saturation is the point at which a solvent is as full of the dissolved solute as possible, and adding more only causes it to precipitate into a solid. This is such an important idea, not just in chemistry, but eventually in weather. If you can understand this idea that there's only so much that can be held in certain situations, and after that it starts to precipitate, and this word precipitate, if you can say that too, thank you, refers to when molecules condense, changing their state as in liquid to solid in chemistry or gas to liquid in weather. So that is the idea of precipitate. So solvents can hold a certain amount of a solute at a certain temperature, and that is what we call its solubility. And when it reaches its maximum, that is called saturation. Saturation is going to become really important during the making of rock candy. We're going to heat up some water, add some sugar to it, pretty much get close to the saturation point. And then we're going to drop down the temperature. And one thing that's going to happen is as the temperature drops, the saturation point also changes. And so the only alternative for all of that dissolved sucrose, which is the name of the sugar molecule, is going to be to precipitate, to become a solid again. And with the little seed crystals that you've added on your stick, that's going to give it a good starting point, and you're going to be able to see those crystals develop. And they actually develop one molecule at a time, and so you get these really beautiful shapes. So I hope you enjoy that, and thank you very much.